There's this idea of the semantic web that when I first heard about, I just fell in love with the idea. It was the obvious next step for the internet.
Sure.
And maybe you can speak about what is the semantic web? What are your thoughts about it? How your vision and mission and goals with Psych are connected, integrated? Like, are they dance partners? Are they aligned? What are your thoughts there?
So think of the semantic web as a kind of knowledge graph. And Google already has something they call knowledge graph, for example, which is sort of like a node and link diagram. So you have these nodes that represent concepts or words or terms. And then there are some arcs that connect them that might be labeled. And so you might have a node with like one person that represents one person, and let's say a husband link that then points to that person's husband. And so there'd be then another link that went from that person labeled wife that went back to the first node, and so on. So having this kind of representation is really good if you want to represent binary relations, essentially relations between two things. And if you have the equivalent of like 3-word sentences, like Fred's wife is Wilma, or something like that, you can represent that very nicely using these kinds of graph structures, or using something like the semantic web, and so on. But the problem is that very often what you want to be able to express takes a lot more than 3 words, and a lot more than simple graph structures like that to represent. So, for instance, if you've read or seen Romeo and Juliet, I could say to you something like, remember when Juliet drank the potion that put her into a kind of suspended animation? When Juliet drank that potion, what did she think that Romeo would think when he heard from someone that she was dead? And you could basically understand what I'm saying. You could understand the question. You could probably remember the answer was, well, she thought that this friar would have gotten a message to Romeo saying that she was going to do this, but the friar didn't. And so you're able to represent and reason with these much, much, much more complicated expressions that go way, way beyond what simple 3-word or 4-word English sentences are, which is really what the semantic web can represent, and really what knowledge graphs can represent.
If you could step back for a second, because it's funny you went into specifics, and maybe you can elaborate, but I was also referring to semantic web as the vision of converting data on the internet into something that's interpretable, understandable by machines.
Oh, of course, at that level.
So we should say, like, what is the semantic web? I mean, you could say a lot of things, but it might not be obvious to a lot of people when they do a Google search that, just like you said, while there might be something that's called a knowledge graph, it really boils down to keyword search ranked by the quality estimate of the website, integrating previous human-based Google searches and what they thought was useful. It's like some weird combination of like surface level hacks that work exceptionally well, but they don't understand the full contents of the websites that they're searching. So Google does not understand, to the degree we've been talking about the word understand, the contents of the Wikipedia pages as part of the search process. And the semantic web says, let's try to come up with a way for the computer to be able to truly understand the contents of those pages. That's the dream.
Yes. So let me first give you an anecdote, and then I'll answer your question. So there's a search engine you've probably never heard of called Northern Light, and it went out of business. But the way it worked, it was a kind of vampiric search engine, and what it did was it didn't index the internet at all. All it did was it negotiated and got access to data from the big search engine companies about what query was typed in and where the user ended up being happy and actually then they type in a completely different query, unrelated query, and so on. So it just went from query to the web page that seemed to satisfy them eventually. And that's all. So it had no understanding of what was being typed in. It had no statistical data other than what I just mentioned. And it did a fantastic job. It did such a good job that the big search engine company said, oh, we're not going to sell you this data anymore. So then it went out of business because it had no other way of taking users to where they would want to go and so on.
And of course, the search engines are now using that kind of idea.
Yes. So let's go back to what you said about the semantic web. So the dream, Tim Berners-Lee and others dream about the semantic web at a general level is, of course, exciting and powerful, and in a sense, the right dream to have, which is to replace the kind of statistically mapped linkages on the internet into something that's more meaningful and semantic and actually gets at the understanding of the content and so on. Eventually, if you say, well, how can we do that? There's sort of a low road, which is what the knowledge graphs are doing and so on, which is to say, well, if we just use these simple binary relations, we can actually get some fraction of the way toward understanding and do something where, in the land of the blind, the one-eyed man is king, kind of thing. And so being able to even just have a toe in the water in the right direction is fantastically powerful. And so that's where a lot of people stop. But then you could say, well, what if we really wanted to represent and reason with full meaning of what's there? For instance, about Romeo and Juliet, with the reasoning about what Juliet believes that Romeo will believe that Juliet believed, and so on. Or if you look at the news, what President Biden believed that the leaders of the Taliban would believe about the leaders of Afghanistan if they, blah, blah, blah. So in order to represent complicated sentences like that, let alone reason with them, you need something which is logically much more expressive than these simple triples, than these simple knowledge graph type structures and so on. And that's why, kicking and screaming, we were led from something like the semantic web representation, which is where we started in 1984 with frames and slots with those kinds of triple store representation. We were led kicking and screaming to this more and more general logical language, this higher order logic. So first we were led to first order logic, and then second order, and then eventually higher order. So you can represent things like modals, like believes, desires, intends, expects, and so on, and nested ones. You can represent complicated kinds of negation. You can represent the process you're going through in trying to answer the question. So you can say things like, oh yeah, if you're trying to do this problem by integration by parts, and you recursively get a problem that's solved by integration by parts, that's actually okay. But if that happens a third time, you're probably off on a wild goose chase or something like that. So being able to talk about the problem-solving process as you're going through the problem-solving process is called reflection. And so that's another. So
it's important to be able to represent that.
Exactly. You need to be able to represent all of these things. Because, in fact, people do represent them. They do talk about them. They do try and teach them to other people. You do have rules of thumb that key off of them and so on. If you can't represent it, then it's sort of like someone with a limited vocabulary who can't understand as easily what you're trying to tell them. And so that's really why I think that the general dream, the original dream of the semantic web is exactly right on. But the implementations that we've seen are sort of these toe in the water,
Yeah.
little tiny baby steps
Yeah.
in the right
You
direction.
should just dive in.
And if no one else is diving in, then yes, taking a baby step in the right direction is better than nothing. But it's not going to be sufficient to actually get you the realization of the semantic web dream, which is what we all want.
From a flip side of that, I always wondered, I've built a bunch of websites just for fun, whatever. Or say I'm a Wikipedia contributor. Do you think there's a set of tools that I can help Psych interpret the website I create? Like this again, pushing onto the semantic web dream. Is there something from the creator perspective that could be done? And one of the things you said with PsyCorp and Psych that you're doing is the tooling side, making humans more powerful. But is there on the other humans in the other side that create the knowledge? Like, for example, you and I are having a 2, 3, whatever hour conversation now. Is there a way that I could convert this more, make it more accessible to Psych, to machines? Do you think about that side of it?
I'd love to see exactly that kind of semi-automated understanding of what people write and what people say.
Mm-hmm.
I think of it as a kind of footnoting almost like the way that when you run something in, say, Microsoft Word or some other document preparation system, Google Docs or something, you'll get underlining of questionable things that you might want to rethink. Either you spelled this wrong or there's a strange grammatical error you might be making here or something. So I'd like to think in terms of Psych-powered tools that read through what it is you said or have typed in, and try to partially understand what you said.
And then you help them out.
Exactly. And then they put in little footnotes that will help other readers. And they put in certain footnotes of the form, I'm not sure what you meant here. You either meant this or this or this, I bet. If you take a few seconds to disambiguate this for me, then I'll know and I'll have it correct for the next 100 people or the next 100,000 people who come here. And if it doesn't take too much effort and you want people to understand your website content, not just be able to read it, but actually be able to have systems that reason with it, then yes, it will be worth your small amount of time to go back and make sure that the AI trying to understand it really did correctly understand it. And let's say you run a travel website or something like that, and people are going to be coming to it because of searches they did, looking for vacations or trips that had certain properties and might have been interesting to them for various reasons, things like that. And if you've explained what's going to happen on your trip, then a system will be able to mechanically reason and connect what this person is looking for with what it is you're actually offering. And so if it understands that there's a free day in Geneva, Switzerland, then if the person coming in happens to, let's say, be a nurse or something like that, then even though you didn't mention it, if it can look up the fact that that's where the International Red Cross Museum is and so on, and what that means and so on, then it can basically say, hey, you might be interested in this trip because while you have a free day in Geneva, you might want to visit that Red Cross Museum. Mm-hmm. And now, even though it's not very deep reasoning, little tiny factors like that might very well cause you to sign up for that trip rather than some competitor trip.
Yeah, and so there's a lot of benefit with SEO. And I actually kind of think this about a lot of things, which is the actual interface, the design of the interface makes a huge difference. How efficient it is to be productive, and also how full of joy the experience is. Like
Yes.
I mean, I would love to help a machine, and not from an AI perspective, just as a human. One of the reasons I really enjoy how Tesla have implemented their autopilot system is there's a sense that you're helping this machine learn. And I think humans, I mean, having children, pets,
People love doing that.
we there's joy to teaching for
Absolutely.
some people, but I think for a lot of people, and that if you create the interface where it feels like you're teaching as opposed to like annoying, like correcting an annoying system, more like teaching a childlike, innocent, curious system. I think you can literally just like several orders of magnitude scale the amount of good quality data being added to something like Psych.
What what you're suggesting is much better even than you thought it was. One of the experiences that we've all had uh, in our lives is that we thought we understood something, but then we found we really only understood it when we had to teach it or explain it to someone or help our child do homework based on it or something like that. Despite the universality of that kind of experience, if you look at educational software today, almost all of it has the computer playing the role of the teacher, and the student plays the role of the student. But as I just mentioned, you can get a lot of learning to happen better and, as you said, more enjoyably if you are the mentor or the teacher and so on. So we developed a program called MathCraft to help sixth graders better understand math. And it doesn't actually try to teach you, the player, anything. What it does is it casts you in the role of a student, essentially, who has classmates who are having trouble, and your job is to watch them as they struggle with some math problem, watch what they're doing, and try to give them good advice to get them to understand what they're doing wrong and so on. And the trick from the point of view of Psych is it has to make mistakes. It has to play the role of the student who makes mistakes, but it has to pick mistakes which are just at the fringe of what you actually understand and don't understand and so on. So it pulls you into a deeper and deeper level of understanding of the subject. And so if you give it good advice about what it should have done instead of what it did and so on, then Psych knows that you now understand that mistake. You won't make that kind of mistake yourself as much anymore. So Psych stops making that mistake because there's no pedagogical usefulness to it. So from your point of view as the player, you feel like you've taught it something because it used to make this mistake and now it doesn't, and so on. So this tremendous reinforcement and engagement because of that and so on. So having a system that plays the role of a student and having the player play the role of the mentor is enormously powerful type of metaphor, just important way of having this sort of interface designed in a way which will facilitate exactly the kind of learning by teaching that goes on all the time in our lives, and yet which is not reflected anywhere almost in a modern education system. It was reflected in the education system that existed in Europe in the 17 and 1800s, monitorial and Lancastrian education systems. It occurred in the one-room schoolhouse in the American West in the 1800s and so on, where you had one schoolroom with one teacher, and it was basically, 5-year-olds to 18-year-olds who were students. And so while the teacher was doing something, half of the students would have to be mentoring the younger kids, and so on. And that turned out to, of course, with scaling up of education, that all went away. And that incredibly powerful experience just went away from the whole education institution as we know it today.